I'm Melanie from Obeo, and I'm here with my colleague Pierre-Charles who's a Sirius tech lead. And we're here today to talk about the work we are doing at Obeo to bring modeling tools to the cloud. So, at Obeo, we've been working on modeling tools for quite a long time now. We're used to work on the development of graphical tools, and Obeo is also a key player in the Eclipse modeling ecosystem, as we are participating to many different kinds of projects like Axeleo, EMF, GMF, eCore Tools, EMF Compare, and one of our great successes is Sirius. This year, we started working on two sides. We are preparing the future of Sirius, and we try to provide new features for the upcoming 6.0 version.
So as we will show in the rest of the talk, we've started ambitious plans for the future of Sirius, but those are for the medium to long term. And in the meantime, we are committed to still continue improving to continue shipping new features and improvement in parallel. So for 6.0, we've added several of these. One of them is new support for configurable diagram background color. So the specifiers can now configure which the color to use for each diagram, and as everything in Sirius, the color can be computed and is dynamic, so it can reflect the current state of the model. It's a pretty small feature by itself, but it illustrates the fact that we try in each release to continuously expand the scope of what can be configured and the visual customization capabilities offered to the specifiers. We've also added a new, more interesting, we call the Magic Edge Creation tool. It's a new tool which will come for free for all diagrams. It's available on the palette here on the right-hand side, and it's a generic edge creation tool, which means it can apply any of the tool defined by the modeler. This means that the end users no longer have to dig into find the specific tool inside the palette, which can become quite complex in large modelers. So the user simply has to activate the tool, select the source and target element, and Sirius will automatically find all the compatible tools. If only one is found, the edge is created automatically, and otherwise, as shown on the animation here, a small pop-up is opened in place, and the user can choose among the compatible candidates. Real-world modelers often need to call into Java code to make complex changes to the model, or to call into Sirius or Eclipse APIs to integrate it with the rest of the system. This is very straightforward in Sirius with the notion of a Java service. You just have to create a Java method with some calling conventions, and you can then invoke it from anywhere inside the AQL expressions defined in the ODesign file. And with 6.0, it's now possible to navigate easily between those two worlds, which previously were separated. So you just have to select anywhere in an expression where you call a service, and you will be opened directly into the correct method. Sirius has always provided an automatic layout algorithms, but it's a generic one which does not always match what you want for all kinds of diagrams. So with 6.0, we've added experimental integration with the ELK framework to improve this. So I'll show you a quick demo. Here I have an eCore tool, an eCore model using eCore tools, which is made by in Sirius. So I have a diagram here. This is a result of the generic layout algorithm. In this case, it's not too bad, but we can see if you can do better. So I can open the definition of the modeler here. And now with 6.0, I have a new option here, where I can select any of the algorithms supported by ELK, for example, DOT, which in this case delegates to the GraphViz tool. And when I implement this, I can see the result directly. And here I will use a different algorithms. All the algorithms provided by ELK are supported, and you can also override all the options they expose. So we expose here all the possible options. I can change the direction and the spacing factor, for example. And you have a nice UI here. You can see the documentation of each parameter. And again, you can experiment, see what configurations matches best your particular kind of diagrams, And when you ship the result to the end user, it's completely transparent. They don't have to deal with all the configuration. They just get a nicer layout algorithms by default.
So I said before that we started to work on the future of Sirius. We are working on retrieving feedbacks about what should be the future of modeling tools. For example, yesterday during the Ignite talk, we gathered some new feedbacks, and so we saw that the Eclipse community who was there in EclipseCon France wants that modeling tools goes to web application and should still be integrated in the classical Eclipse IDE, but also in the future of cloud IDEs like Theia and Che. Another question was, what do you expect from modeling in the future? So it seems that you want something that is fast, simple, and easy. Me too. I hope so. And yes, you want automatic layout, easier integration. You expect that would be scalable, lightweight. There is more documentation, and so in the end, your modeling tool should be beautiful. So thanks for all your feedback. We still have some others. Yesterday also I asked what kind of features do you expect from the modeling tools. In the end, you think that modeling tools must be editable diagrams with auto layout, but I'm quite surprised that you want trees, because usually when we ask people if they are using trees in Sirius, they are not using that, so that's quite new for me. And they expect that you expect that we would provide dashboards, and that's a good news because we are working on that. So, modeling tools we have today, based on Sirius, look like this. You have a graphical editor with a palette to manage elements, and we can also have a fully customizable property sheet for fine-grained edition of individual properties. Today, Sirius is based on the Eclipse platform. Consequently, the graphical modelers are desktop applications. So, as desktop application, you have a software that must be installed on your computer. This means that the deployment of your graphical modeler can be painful, and it would be the same for all the future updates. And this is especially true in a large deployments where teams must collaborate and thus all versions must be in sync. And we face these deployment issues more and more with the expand of the Obeo Designer Team Edition. Modeling tools based on Sirius tomorrow could look like this. So you still have a graphical editor with a palette to manage elements. The main difference is that tomorrow, Sirius applications will be based on web technologies. Consequently, the graphical modelers will be cloud applications. And with cloud application, you will no longer need to install it. You can use it directly, and so update will be transparent. Your graphical workbenches will be easy to access from any browser and from any device. And so it will adapt to the workload increase. Our purpose is to carry the spirit of Sirius, easily develop modeling workbench, but render in a browser. So what you have in Sirius is the ability to define your modeling workbench in a configuration file. There is no code generation involved. Everything is interpreted at runtime. And it is flexible even for complex models. So we will keep all those things, and we will allow you to define easily workbenches running in the cloud. So where are we today? So we're going step by step and work on different sides.
So our first step is to introduce web technologies inside the existing Eclipse views. We chose this approach to be able to provide right now new features which provide a modern look and feel that could be difficult to achieve using classical SWT and JFace APIs. And at the same time, the same approach allows us to make sure that the new features we provide are still available right now to all our users which still rely on the Eclipse platform itself, on the classical Eclipse platform. So we are developing all these new features using, on top of a simple independent library of React components. It's available here on the new GitHub repo for Sirius. And those web UI components are used to build richer UIs. So for example, here we have developed a kind of dashboard which shows all the Sirius projects available running inside the server, and you can dig into their details. It can be displayed here inside a classical browser, and it can also be integrated into a classical Eclipse RCP UI. So here we have a classical, it's a completely normal Eclipse, which uses a Sirius session editor here, and we've added a new tab. And inside the tab, it's an embedded web browser which uses this library to display new UIs. So this approach is used to provide a new feature introduced in 6.0, which we call workflow. It's a new way to define a kind of dashboard, which allows specifiers to define high-level tasks that can be used to help the users to guide them through the usage of their modelers. So here on the left, we have a Sirius configuration file with a new part here. We define a workflow, and inside you can define different kind of elements. I'll show a demo. And this is how it's rendered at runtime on the end user's workbench. So it's using the new web UI. So let's see a small demo. So here I'm using UML, a simple UML model using UML Designer. So we have a classical Sirius session editor, which was introduced last year, but we've added a new page here. And it's using a backend running inside Sirius, which uses HTTP services to expose the structure of the session. So we have high-level information about the session, and here we can see different kinds of actions that, in fact, are configured directly in the .odesign file here. And we can, inside of this, you can use all the kind of, you can define tools. The effect of the hyperlinks here are completely arbitrary, and you can use exactly the same kind of operations that you use for any kind of tool in Sirius. For example, here I have one which creates and opens a new diagram, and it's integrated inside Eclipse. And here we can see operations to open contextual help, or even maybe directly go to a website to report an issue, if the website works. Well, it's GitHub. Trust me, normally it works. OK. C'est à toi.
J'attends juste que tu remettes le slide. Okay.
Je veux bien. Attends.
Wow.
Sorry about that.
Okay.
C'est Internet.
Sinon, tu le laisses en mode plein écran.
Ouais. So we'll continue like this, sorry.
Sorry.
Comment cache? Non, je sais pas.
Okay. So we're also working on making Sirius independent from the Eclipse platform. Here, the idea is to make the Sirius code base more modular. We're trying to isolate the core business concept from the current Eclipse-based technology stack, like the Eclipse UI, GMF, the workspace, and even the Eclipse runtime itself. So we'll work on this progressively over several versions, making sure Sirius always keeps working even in the classical Eclipse-based context. Then, the end goal is to get a set of core components that can be reused both in Eclipse and, more to the point, inside a web server exposing its services to any web client through a well-defined protocol. These new developments on the architecture of Sirius will be contributed as open source to the existing Sirius project, and as it is the case today with our team edition, some extensions will remain proprietary. So today we have the first version of Sirius running headlessly. Here we have a Sirius server running, and so we connect to a Sirius session from the browser. we have a simple dashboard which lists the existing projects available from the session. And we have, in this example, one simple project, so we can select it. And it opens a new page detailing the semantic resources and the representations available on this session. And on the right side, we have the workflows, the new workflow section that defines the default actions available. For example, we can create an empty semantic model. And we are also able to create modeling elements in it. So then it is possible to create a new diagram also. And we can open this new representation from the representation sections. And so here we have created a tool dedicated to one thing, and it is easy to access. It is running out of any IDE.
Yes, to bring those technologies further to the web, we were convinced from day one that we needed to base our work on a standard communication protocol. So today, our modeling tools are architected as can be seen on the left. It's all based on Eclipse technologies, and everything runs in process inside the Eclipse runtime. So all parts can communicate freely using plain Java calls. But we want to go to an architecture which looks more like the thing on the right, with a separated client and server. So Sirius will be split into different pieces which can communicate across the network. And so in the last few months, there was a large-scale effort, and you've seen some of these yesterday, around the language server protocol, which is used to ease the integration between language servers and actual IDEs and text editors. And we find that approach very inspiring, so we decided to try to federate people working on an equivalent for the graphical modelers, which we call Graphical Server Protocol. So the purpose of the Graphical Server Protocol is to lower the cost of integrating a graphical tool with a front-end platform. It's an open source project which is available here on GitHub, and it's based on we work on it with people from Typefox. We were inspired by Sprotty. And it defines the communication protocol between, on the server side, a server which knows about the structure of the diagrams, and on the actual semantic models on the side, underneath, sorry. The server knows about the layout and the styling operation, which tools are available and what are their operations. And on the client side, there's a rendering technology, for example, based on a browser, which actually interacts with the end user. So this project, the Graphical Server Protocol, focuses on the specification of the protocol, and by itself it does not aim to create an implementation. We at Obeo will provide an implementation in Sirius, but everyone is welcome to participate to the definition of the protocol, and also to the implementation of to its reference implementation based on Sirius and Sprotty. The purpose is really to federate the different efforts which are ongoing to provide this kind of integration of graphical tools on the web, and so that everyone goes in the same direction.
And today this protocol is mostly 95% the protocol defined in Sprotty. So we're trying to just upgrade this protocol in the future in order to be more adapted to the edition part of graphical modeling. So, thanks to this, we finally reached our first touchdown by rendering series diagram in browser. So, on the next video, then you will see that just by updating the series configuration, you can see in the browser how the elements are rendered, and you can work on the look and feel of your modeler iteratively. So here at the beginning, all the edges and labels are black. We updated the series configuration to set the main labels in blue and the edges in blue also. And then immediately when the configuration is saved, you see that the colors change in the browser. This is exactly what you are used to do with Sirius. And so you would have the same abilities with rendering in the browser. And you should remember that for the first diagram components will be contributed this fall to Sirius. So you will be able to try that by your own normally in October. So this prototype is based on Sprotty, and we chose Sprotty because it is really a simple JavaScript graphical library, which is not yet mature, but we know that it will be possible for us to contribute to it and make it evolve according to the Sirius needs. It is small, lightweight, open source, and very well architectured. And furthermore, it is well integrated with Eclipse Che, which provides auto layout. And thanks to Typefox for the, I really want to thank Typefox for the really great work that they are doing on these projects, because they are really filling a gap for modeling going to the web. So if you want more details about Sprotty, you should attend the session dedicating to this topic. I think it's Sprotty Graphical Views for Web Application. It would be after the morning break in the same room, and it would be done by Jan and Miro, I think. So do not hesitate to get more details on Sprotty to this session. And for the other components we are using, we try to rely on really mainstream technologies, so as React for the front end and JT for the server side. So a diagram can provide different layers, and you can go to the demo.
C'est pas celui-là, c'est la vidéo.
Okay, this one is okay.
This one's okay?
Yeah. A diagram can provide different layers, and so this demo shows the capability to enable and disable layer. You can disable and enable some layer. So you see that it will filter accordingly the graphical elements visible in the diagrams and the tools available in the palette. So you see that the layout is automatically recalculated each time a layer is enabled in order to provide a smart layout at any time to the end user. So today we can take any existing graphical workbench specified with Sirius and render it in a browser, but we render the graphical elements, but also we interpret at runtime the tools available in the palette according to the tools defined in the Sirius configuration. And as we can see on this demo, it is possible to create new data model elements thanks to those tools from the palette.
So we are now able to run our first prototypes on Sirius based on as a classical web applications, but we are also working toward integrating this into the next generation of cloud IDEs. So one such integration is with Theia, with a new cloud and desktop IDE developed by the Typefox guys, and we integrate Sirius with the help with inside this IDE. So here I have a small demo. Here I have a Theia server running, and we've added, so by default Theia provides a workspace here with your files. We've added a new view called Sirius here, which allows me to see the structure of the workspace exposed by a Sirius server this time. So it's the same server we used earlier, and we have exactly the same kind of rendering and the UI. We can show the palette, create new elements, hide, etc. So exactly the same rendering, but it's inside the Theia IDE. Finally, as Eclipse has decided to integrate Theia as their new technology for the UI side instead of their old JWT IDE, we're also working on integration at this level directly with Che. Here we have a small video. So here we have a Che workspace, a Che UI, and we had a new sidecar, I think it's a technical term. So here Che provisions a new Theia-based Sirius workspace.
In fact, it's a Theia with a new extension for providing Sirius capabilities. So it's this extension you see just before, but now it is running on Che.
Yes, and it's provisioned automatically. You don't have to install something locally. So we see the same kind of UI with a new Sirius view, and we get the same diagram as before.
So you still have the Theia IDE, but with the integration with Sirius diagram. So it is you still have exactly the same capabilities, but it is easier to install. So to sum up, if we look to the Sirius timeline for the next month, you see that we will keep working on the existing Sirius project, and we will reintegrate the new web-related features and components. And this summer, we will continue our work on the modularization of the architecture. And for the 6.1 this fall, that should be in October or mostly, we will stabilize the workflow dialect and contribute a first version of web-based diagrams based on the Graphical Server Protocol. So as you saw in our demos, based on our experience, we are making Sirius evolve to bring modeling tools to the cloud, but we need you to go beyond. As open source is in our DNA, most of these changes will be contributed to Sirius, and the actual Sirius project will evolve to a client-server architecture, but we need you to share with us your needs about graphical modeling in the cloud and would really welcome your feedback. So we would also like to invite all of you to participate to the effort done on Sprotty and the Graphical Server Protocol to make this open collaboration and to provide a common protocol for graphical editors. And finally, remember that we are available to work with other organizations to bring modeling tools to the web, including integration with web and cloud tooling. And yesterday, during the Ignite, I proposed you to ask me anything about the future of modeling tools, so I just gathered some of those questions, and I will try to answer it. So someone asked if we are looking for hosted platforms. Yes, in the end, we want to be able to provide easily with Sirius a way to provide hosted platforms, so for modeling tools. Someone asked, is there a good microservice modeling method or tool? I think that I have no idea about what is exactly the question, so I can't answer it, sorry. If this person is in the room, I could discuss with her later. Someone asked, is it a goal to attain 100% of code generation? Definitely not. This is not the goal of modeling tools, usually. Someone asked if, can I integrate Sirius in a web app? And when? So yes, our purpose is to be able to integrate Sirius in a web app. And when you should be able to do that for the first prototype in fall this year. And why the need for tables is so underestimated? As I said also, I was really surprised by that. You put the trees before the tables, and usually it is our customers are asking for the other things, so tables first and trees after. So I don't know. And the question after was, what's the most important feature we're working on? So the modularization of Sirius in order to put this on the web is the biggest work we have to do for the next months. And another question was, will modeling tools be involved with analysis tools? Definitely, I think that would be the future of modeling tools, to be linked to other kind of tools like analysis tools. And the last question, which has the most vote, was, is it a boy or girl? So yes, it's a boy. And so thanks for your attention, and if you have any question, we still have time for that, so do not hesitate. Do you have a question? I know that it's hard with this room to ask questions, so do not hesitate to come to us and to discuss later. Yes. Okay, one question.
I guess for diagrams, you were using Sprotty.
Yeah.
At the Sprotty demo, they told me that they didn't have diagram specific information, like diagram positioning. Did you work around that by relying on the ARD model, or can you not have diagram specific information such as nodes and node position?
So right now we are working on keeping information on the IRD elements, on IRD files.
Models.
And so we still have we can have this kind of information.
Yes,
so
we have this information.
We have this information on the server side, not on the client side. Yeah. But yeah. Other questions? Okay. Thanks for your attention, and do not hesitate to discuss with us after that.